It turns out FURB-E owners love their new electric bikes, and they've found way more ways to use them than we ever imagined. As a result, they've been submitting all kinds of requests for new FURB-E accessories. And I have to admit, some of them are really good. We need to find a way to harness their enthusiasm and react fast by turning their best ideas into actual products. In addition to that, Brian's already shown a lot of interest in developing a smart device. Luckily, I received one of the most brilliant submissions I've seen so far. What better accessory to complement the FURB-E than a FURB-E? This guy will be jam-packed with features. It has a speaker to blast tunes while you cruise. It'll also speak your navigation instructions to you because it'll be powered by Google Assistant. So not only will those big ears be listening to your voice commands, you can also flick them to activate a turning signal for taking turns in heavy traffic areas. This thing will be equipped with a GPS sensor for all of the obvious reasons like navigation and speed monitoring. But what if your battery's approaching 50% and you're pretty far from home? In that case, the FURB-E's eyes will glow to notify you it's time to turn around. Now, we know we designed this thing to be light so it's easy to carry, but that also makes it easy to steal. So the FURB-E will also be equipped with a motion sensor that will automatically activate as soon as the key is removed. If an intruder tries to hoist it, this little guy will start screaming, which will freak out and scare away the most intimidating thieves. So how's that for a smart device? Looks like I'll have my work cut out for me. Fortunately, I'll have a head start because our community member that came up with this amazing idea also provided me with a 3D design file. Unfortunately, it's a 3MF file, which is pretty much an enhanced STL file, something we haven't had a great history of importing. That is, until 2018. Mesh files are very different than CAD files. Rather than being able to precisely calculate any point on any surface with an equation, mesh files are approximated graphical representations of geometry that are made up of thousands of tiny facets. With 3D scanning, 3D printing, and many graphically focused modeling tools out there, mesh formats are becoming more and more popular. So rather than just opening the files to graphically preview the geometry like we have in the past, we can now edit them. By converting the default mesh graphics bodies to mesh solid bodies, we'll be able to cut section views, apply materials, check mass properties, and even edit the design with downstream features. I need to cut out an internal cavity for all of the electrical componentry we'll be packing into this FURB-E. By creating additional solid bodies and converting them into mesh solid bodies, we can use Boolean operations like the combine feature to subtract one mesh body from another. In an assembly, it could be tricky adding mates to each of these tiny facets. Ideally, I'd prefer a nice, smooth bottom surface to locate the FURB-E perfectly offset from the handlebars. To do so, I can convert a series of mesh facets to a single surface. This works for planar, spherical, cylindrical, and conical faces by just stroking a paintbrush across the facets to average them out while respecting their overall boundary. For prismatic geometry, you could essentially rebuild the entire model using this technique. There are many more features that are compatible with the new mesh solid bodies, which really broadens the scope of files, businesses, and disciplines we can now collaborate with. Now that we have a place to install the internal components, I'll need the help of our electrical hardware engineer, Ingi, to help complete the design. I'm an industrial designer, and I have basically no background in electrical engineering. But with Ingi using Solidworks PCB, I can install PCB connector, which will allow Ingi and me to collaborate seamlessly. Rather than sending countless files and emails back and forth to each other, I can begin the design by specifying the board outline, mounting holes, and critical component placement, and then push my design over to Ingi. Without translation, she'll be able to open my assembly and begin designing both her schematic and PCB layout. As we're exchanging our modifications, we can add comments to better our communications and document our changes. If Ingy or I relocate any of the components, an animation of the new location can be previewed before we choose whether or not to accept the changes. Being able to watch this board take shape within the space I've suggested assures us it will both fit and function on the first try. Having added all these costly components to our FURB-E, we need to protect it by making sure it's firmly secured to the handlebars. As much as I'd love to take on the modeling challenge of surface modeling this mount from scratch, there's a much easier technique in SOLIDWORKS 2018. It's called topology optimization. Starting with a primitive shape like 3 extruded cylinders to represent the overall maximum volume, we can specify the key performance parameters of this design and allow SOLIDWORKS to whittle down the geometry to only the necessary volume required to meet our demands. I need to define where the mount will grip onto the handlebars. To do so, I'll drag and drop a pair of FURB-E footprints into my design, because who doesn't have that in their design library? After wrapping them onto the handlebars, I can define the faces as a fixture for the topology study. After accounting for the load of the FURB-E and setting a design goal of best stiffness to weight ratio, I can let SOLIDWORKS work its magic. Iterating through thousands of calculations in just minutes, we'll arrive at an optimal geometry for our needs. Best of all, this mesh body can be converted into a mesh solid body for more downstream edits, just like I showed earlier. And of course, it fits perfectly into our top-level assembly. Just like 3D printing is revolutionizing the future of manufacturing, I expect this simple and powerful workflow to revolutionize design. It's amazing the speed at which we can take an idea and turn it into reality. Starting with a model that we were previously only able to graphically preview, we evolved it into a solid model fit for assembling and manufacturing. We bridged the gap between mechanical and electrical design by unifying our design platform, and we used a cutting-edge process to automatically generate an optimal design for a mount. This is the future of design and collaboration. So please keep an eye on these cutting-edge technologies SOLIDWORKS continues to pave the way with, as they're only going to get better, faster, and more intelligent. You don't want to be slow to adopt these new features, as they can greatly improve your product's time to market. So stay tuned and continue to watch the Concept to Consumer video series for more game-changing and innovative workflows.